Welcome to this lesson on centripetal acceleration. Centripetal acceleration is a fundamental concept in circular motion that helps us understand how objects move along curved paths. The term centripetal means center-seeking, which gives us a clue about the nature of this acceleration. Throughout this lesson, we'll explore what makes objects follow circular paths and the physics behind this fascinating phenomenon. Centripetal acceleration is the acceleration that points toward the center of a circular path. When an object moves in a circle, its direction is constantly changing, even if its speed remains the same. This continuous change in direction means the velocity is changing, and whenever velocity changes, there must be an acceleration. This acceleration is always directed toward the center of the circle, keeping the object on its curved path rather than moving in a straight line. Let's examine three key characteristics of centripetal acceleration. First, it is always directed toward the center of the circle at every point along the path. Second, the direction of this acceleration changes continuously as the object moves around the circle, always pointing inward. Third, centripetal acceleration is perpendicular to the velocity at every instant. This means the acceleration vector and velocity vector form a 90-degree angle, which is why the speed can remain constant while the direction changes. This diagram illustrates the relationship between velocity and centripetal acceleration. The object shown in red is moving along the circular path. The green arrow represents the velocity vector, which is tangent to the circle, meaning it points in the direction the object is moving at that instant. The red arrow represents the centripetal acceleration, which points directly toward the center of the circle. Notice how these two vectors are perpendicular to each other. This perpendicular relationship is crucial because it allows the acceleration to change the direction of motion without changing the speed. The magnitude of centripetal acceleration can be calculated using a specific formula. Centripetal acceleration equals velocity squared divided by radius. Here, a sub c represents the centripetal acceleration, v represents the velocity of the object moving along the circular path, and r represents the radius of the circle. This formula tells us that centripetal acceleration depends on two factors: how fast the object is moving and the size of the circular path. Notice that velocity is squared, which means doubling the speed will quadruple the acceleration. There's an alternative way to express centripetal acceleration using angular velocity. The formula is centripetal acceleration equals omega squared times radius. In this version, a sub c still represents centripetal acceleration. Omega represents the angular velocity, which measures how quickly the object rotates around the circle in radians per second, and r is still the radius. This formula is particularly useful when dealing with rotating systems, where angular velocity is more convenient to work with than linear velocity. Let's explore some important insights about centripetal acceleration. First, there's a quadratic relationship between speed and acceleration. This means if you double the speed, the centripetal acceleration increases by a factor of 4. Second, the radius of the circular path matters significantly. A smaller radius requires greater acceleration to maintain circular motion at the same speed. This is why sharp turns are more challenging than gentle curves. Third, it's crucial to understand that while the speed remains constant in uniform circular motion, the velocity changes continuously because velocity includes both magnitude and direction. Centripetal acceleration appears in many real-world situations. When a roller coaster navigates a loop, riders experience centripetal acceleration directed toward the center of the loop. When a car turns around a curve, the friction between the tires and road provides the centripetal force that creates the acceleration toward the center of the curve. Satellites orbiting Earth experience centripetal acceleration directed toward Earth's center, which keeps them in orbit. Even a person riding a Ferris wheel experiences centripetal acceleration pointing toward the center of the wheel. Understanding centripetal acceleration helps us analyze and predict the behavior of objects in circular motion across countless applications in physics and engineering.
If you like this video, hit that like button and don't forget to subscribe. Visit codelucky.com for more such useful content.